Here we have a main window on the left, which shows an array of 512 by 512 elements of the reconfigurable array. Each of the 64 blocks, in itself 64 by 64 reconfigurable elements, configured to implement a circuit for updating the temperature of a single mesh element. In the upper right is the 8 by 8 mesh being simulated. The display is color-coded, red being hot and blue being cold. The elements along the edge of the mesh represent boundary conditions. By pointing the mouse to a boundary element and using the scroll wheel, the boundary temperature can be changed. As soon as a change is made, the client sets the new temperature on the input of the corresponding mesh element's circuit, and you can see this change propagate throughout the entire circuit on the left. As boundary elements are made hotter, the inside of the mesh also begins to turn more red. The thermal coefficient is small, and so the changes propagate slowly. But as more edge elements are made hotter, the entire mesh becomes hotter. This represents a useful visual tool for observing the heat flow through the simulated surface. Making many rapid changes cause the system to lag, but by turning off the element level display on the left, the system operates nicely at interactive speeds. Now we cool down some edge elements and see how these lower temperatures propagate through the mesh. Here is a close-up of the element level display. And here is a close-up of the mesh itself as the boundary is made uniformly cold.